Hey everyone, welcome to part 3, predicting unseen data. So our model is really only useful on data that it has yet to see in the future. In the last video, we built our model on the entire data set that we had up to September 1st. We did not see how it would perform on data that it has yet to see, and that's what we will do in this section. So instead of looking at the entire data set through September 1st, we'll stop at May 30th and train our model only on this subset. So Y will be the subset of cases in Texas up to May 30th. We will use the least squares function again. We will then be able to make a prediction on all of the data. So that's what we do over here. We get the entire length, and then we make the prediction on the entire length of the data through September 1st. We just turn it into a series, and then we make the plot. So the blue line is what actually happened, and the orange is what our model was built on. And you can see that it does follow the blue line closely. In fact, you can't really see the blue line because it's on top of it for the most part. And then the green line is what our model predicts on the unseen data. And as you'll note, it does actually do a somewhat good job for the next month and a half. So it does provide some value in this particular example. But then after a couple of months, it starts to veer off into infinity, whereas the actual data set goes, flattens out. So the difference becomes substantial after a couple of months. So our model, if we were to evaluate it after a couple of months, would do very poorly. So this is what really ultimately matters, is that how it does in the future. So we'll build different models that do not veer off into the future, or do not veer off into infinity in the future. But this is the procedure we'll use to evaluate. How well does it do on unseen data? All right, so that's it for this video on predicting unseen data.